All right, let's get right into it. We talk a lot about the clean energy transition, but how does it actually get built? Today, we're going to unpack the incredible engineering blueprint behind the giant batteries that make a green-powered world a reality. We're going from an empty field to a powerhouse of the future. Look, we are smack in the middle of a renewable revolution. Solar panels, giant wind turbines, they aren't just cool ideas anymore. They are a huge part of our energy landscape, right? They're harnessing the raw power of the elements. It's amazing stuff. But there's a catch. And there it is. That's the fundamental problem we have to solve. Renewables are fantastic when they're, generating power, but they're not always on. That intermittency, that's the single biggest hurdle we face. So what do you do on a calm, cloudy night? Well, that's what you do. You build a power bank for the entire grid. And we're not talking about the little batteries in your TV remote. These are massive utility-scale systems built to hold staggering amounts of energy and then release it exactly when we need it the most. Honestly, solving this storage problem, it's the whole game. This isn't just some small upgrade to the system. It is the key, the absolute key that unlocks the full potential of renewables. It's what turns a sometimes-on power source into a constant, reliable supply we can all count on. The core technology here is called a BESS. That stands for Battery Energy Storage System. The easiest way to think about it is like a giant rechargeable battery for the grid. It can soak up all that extra energy on, say, a super sunny afternoon, and then push it right back out when everyone gets home and turns on their lights. And this just lays it all out, doesn't it? On the left, you've got the old problem, power that comes and goes, an unstable grid, and literally wasting clean energy because you can't use it the second it's made. But on the right, with BSS, you get the solution, 24/7 reliable power, a stable grid, and a way to save all that good, clean energy for when we actually need it. Okay, so how do you actually build one of these massive things? Well, it's a huge undertaking that starts way before anyone even thinks about pouring concrete. It all begins with a vision, an empty field, and a master plan that is incredibly detailed. The whole process is this massive four-part journey. It starts with the big picture, strategic design. Then it gets into the real nuts and bolts with precision engineering. After that, it goes global with strategic procurement before you finally break ground in the accountable construction phase. Let's walk through it. So that first step, strategic design, is all about the groundwork. And I mean that literally. You start with foundation analysis, geotechnical surveys to figure out what the land itself is like. From there, you map out the entire footprint, including the all-important connection to the main power grid. And crucially, you also design the system's digital brain, its smart architecture, with cybersecurity baked in from day one. The level of detail here is just mind-boggling. I mean, these blueprints, they go way beyond just the buildings. They cover everything you can imagine. We're talking drainage systems to protect the site, all the way to these super complex load flow studies, which are basically digital rehearsals to make sure the battery plays nice with the grid. Absolutely nothing is left to chance. All right, with that blueprint locked in, the focus shifts to actually forging the components. This next part is all about precision engineering and a huge global sourcing operation to bring that design into the real world. So where does all the money go? Well, it's not just one giant battery, right? It's more like a symphony of interconnected systems. You've got the battery systems themselves, of course, but you also have power conversion systems, all the hardware for grid integration, and the sophisticated control systems that act as the brain of the whole operation. And here's the number that really tells the story. Almost half, 45% of the entire technical investment goes into the battery systems alone. That is the absolute heart of the technology. It's where the energy is stored, and getting this part right is everything. Now, sourcing these parts means holding them to incredibly high standards. This is not like buying something off the shelf. Every single piece is checked against these really strict benchmarks. For example, the battery containers have to have certified fire suppression. The power conversion systems need to be over 98.5% efficient. The management system, it needs certified cybersecurity. It's a true checklist of excellence. You know, this whole phase is really a story of two different scales. On the one hand, you have the unbelievable micro detail of the engineering plants. And on the other, you have this massive global logistics operation needed to find and ship all these components, often as hazardous materials, to the site on a perfect, just-in-time schedule. Okay, now for the really exciting part. This is where all that planning and engineering and sourcing finally comes together. We are officially moving from paper to power. We're in the construction and commissioning phase, where this thing actually takes shape.
The build itself happens in three main stages. First up is the civil work, pouring foundations, putting up all the fencing, building roads. Then comes the electrical work, which is a massive job of running cables and building the switchyard. And finally, you tie it all together with system integration, installing the central nervous system, the control systems, and layering in all that cybersecurity.
This quote right here, it really captures the climax of the entire build. This is the moment of truth, connecting this giant battery to the public grid. And it's not like just flipping a switch. Oh no. It is a delicate, super high-stakes dance that's done in perfect sync with the utility company to make sure everything goes smoothly and safely. But before that big moment, every single part of the system gets put through its paces. There's a whole testing plan that validates everything, from how it charges and discharges, to the safety systems, to its efficiency levels, to make absolutely certain it performs exactly like it was designed to. So, we've gone from an empty plot of land to a fully commissioned power plant. Let's just step back for a second and look at the big picture. Why is this so important? What does this really mean for our energy future? Well, it's about scale. Technology like this can support a renewable energy portfolio of 5 gigawatts or even more. That's a staggering amount of clean energy, enough to power millions of homes, and it's all made reliable and available around the clock. And this is the beautiful result of all that work. A silent, powerful reservoir of clean energy just waiting. It's the buffer that keeps our grid stable. It's the resource that keeps our lights on, using power that might have been generated hours or even days ago by the sun and the wind. And that right there is the ultimate takeaway. This isn't science fiction anymore. By tackling that storage problem head-on with incredible planning and engineering, BESS technology is the final piece of the puzzle. It makes a truly renewable, stable, and reliable power grid an achievable engineering reality. This incredible feat of engineering solves one of the biggest challenges we have today. And so it leaves us with a pretty important question for the future. As our world keeps changing and demanding even more clean energy, what's the next great blueprint we need to design and build together?